Hello, welcome guys back to the ENIACs, and today we're gonna learn about something called as force, what actually forces. So going back into past history, unraveling the book, opening the book, then we see something like there are people in Greece who were keen to know about why actually things move. So there was one guy called Aristotle. So he said because my thing moves because it has energy, and my thing stops because the energy gets over. So people thought, and then in 1600 or something, this guy called Newton came up with new idea that what actually means force, inertia, inertial frame of reference, and all relativity. Again discussed by Galileo and Galilei. Then in 1600, of course, and then we move on to what actually are forces. So there are kind of four forces which govern our world, and we are in search of fifth one. So which is called quantum gravity. Maybe maybe it's there. I mean, I don't know about it. Never wrote anything about it, so I kind of don't know. So let's start with first force. There are actually four forces named uh, strong nuclear force, weak nuclear force, gravity, and electromagnetic force. So gravity, we know it's because of mass. It's always because of mass. All right. The more the mass thing is, or the more the mass it is, the more the gravity is. Then second comes electromagnetism. Electromagnetism is another. It's a light. It's a vector. It's a vector. Then it has electric field, magnetic field, and direction, velocity, each perpendicular to each other, like like this, like this. The direction of the velocity determines where the wave is going to move. All right. Then comes strong nuclear force and weak nuclear force. Weak nuclear forces supposed to be have an atom. So we draw a nucleus here. This is a nucleus. It's a dense part we don't know. Then we have an electron here revolving around a circular orbit. So this circular orbit is determined by this interaction between this and nucleus. So this thing is designed, I mean, run by this dense nucleus and charge. So the electron revolves around it in a fashion. Maybe we have seen s orbital, p orbital, d orbital, and all stuff like that. So I'm not gonna go into that, but then you gotta know about all those things because it's a basic, alright. So now we have this electron here, I charge minus charge is minus negative, and we have a same counterpart of electron representing proton, that is positive part up here with neutrons. Neutrons are kind of uh, they don't possess any charge. They have a mass around equal to a proton, or maybe something more like more than proton, half, like it's little bit. So it's more than a proton. Then after this thing, the position is decided. All right. So now we know where the electron is, where it will be. So to hold that electron has an escape velocity. To hold that electron, we need a force. That force is provided by weak force. Then we come zoom into this thing, this nucleus thing. We have many other particles, subparticles are into it, maybe gluon, muon, tau, quark, up quark, down quark, and all stuff like that, which comes under particle physics. Later on, we're gonna deal with that too, baryons and all. Then this nucleus has neutrons and protons. So how can something be glued? I mean, uh, something can. I mean, can you create something like a bunch of positive charge up here, a bunch of negative charge up here? You can't do that because it will collide. I mean, it will explode. It will become a bomb. It will be a bomb, of course. So you can't have something like close, or maybe you can't have something like dense region having positive region because positive ripples. So to overcome that, we have a strong force here between neutron and proton. All the protons, that is called strong nuclear force, and we named it as a gluon due to gluons particle. We have it, and all these things do have mass. All these things do have mass and charges. So mass thing, so the mass, all right, the mass thing is kind of uh, equal. I mean, same to everybody, or maybe charge thing same to everybody except neutron, or they convert into proton, and all the reaction between this uh, neutron and proton and electron takes place. I mean, it's a fluid, like, dynamic model. So it goes up to a higher level, comes back, or changes, gives out two photons, or becomes something else, then gives two things, or takes two things, becomes something else, light and stuff like that. So this thing is, this is how the thing works. And we're not gonna talk about gravity much because it's actually a big thing, and we need a lot of time in order to understand it. And also about electromagnetic force. This the electromagnetic force is the quite. I mean, we know many thing about it. It's like we know really good thing. I mean, we know about it, electromagnetic force. So you're gonna go something like, if this thing is a wave, and this, which I was talking about, this is suppose an electric field, and coming out of this is magnetic field, and here is the velocity. So I was saying, either motion of that electromagnetic wave will always be decided by the velocity vector, and this electric field and magnetic field will always be going to perpendicular to each other, no matter what. So that's how they like move. Yes, and that's all for the forces thing. I think we didn't talk about how force dominates, why it's called strong nuclear force. No, we did, but then comparing it with Coulomb's force of attraction, why we don't take gravity into it, because it possesses mass. So we should take gravity also. But then why did we don't take? It's because of it's it's very negligible. So that's what quite amazing in physics is, something very negligible, you can't take it, you don't want to take it, and something which is negligible, you take it. I mean, uh, have you ever like, do you know uh, uh, the value of Planck constant? It's 6.6 10 to the power minus 34 aka units. Why do we take it? It's minus 34. Why do we take it? No, I don't know. Then comes uh, this thing, this force, gravity, and your interaction between gravity and Coulomb force. Why do we don't take this Coulomb force? I know it's because it's very less, 10 to the power minus 23, 43, or maybe anything. But why don't we take it? Because we take Planck's constant into the picture. Why we don't do? quite a mystery. I really don't know. If anybody knows, please comment down below. And that's all for now. Love you guys. Bye.